Hey, welcome to I Used AI to Write My Playwright Tests. Here's what it got wrong. I'm Scott, and today we're walking through a Playwright test project that I built specifically for testing Shadow DOM, one of those topics that comes up constantly in modern web testing, but doesn't always get a clear explanation. I also built this site that we'll be using, ml-minds.com. It covers Shadow DOM, nested scrolls, iframes, and full auth flow. Everything is live, everything is real. Link is in the description. The project is called Vault. It's open source and the GitHub link is also in the description. We're using Java, Playwright, and Cucumber BDD with Gherkin. So if you're coming from a SpecFlow or JUnit background, you'll feel right at home. Now, before we go any further, I want to be upfront about something. Parts of this project were written with the help of AI, and I want to talk honestly about that, because I think it's more useful to you than pretending it was all handcrafted by me. The AI got a lot of things right, but it also produced code with real problems. Logic gaps, missing flexibility, violations of DRY, don't repeat yourself. And spotting those required a human who actually knows how to code and how to think about test design. We'll walk through specific examples as we go. Let's get into it. First, what is Shadow DOM and why does it matter for testing? To see Shadow DOM, you look for Shadow Root in the Developer tab. So here we go. We'll start at ml-minds.com. On the Labs drop-down, choose Shadow DOM. Now right-click on the Shadow form and select the last option of Inspect. Now expand the drop-down caret on Shadow Demo widget and then drill down further by expanding the Shadow Root caret. Shadow DOM is a web standard that lets a component encapsulate all of its own HTML and CSS inside an isolated tree. You see this a lot with web components, custom drop-downs, date pickers, media players, and form widgets. The key thing from a testing perspective, elements inside a shadow root are not directly queryable from the main document. A regular document.query selector won't actually find them. Traditional Selenium and older Playwright versions would just return null and your test falls over. There are two types of shadow root, open and closed, and here we are looking at open ones. Open means the browser exposes the shadow root via element.shadowroot, which is what allows both Playwright's auto-piercing and our JavaScript traversal to work. Closed means element.shadowroot returns null. External code can't touch it. Everything we're doing today only works because the Vault widgets use open shadow roots. The Vault test site has three widgets inside Shadow DOM, a form, a counter, and a select drop-down. We'll be testing all three. Now let's take a quick look at the project layout before we run anything. We have a standard Maven layout. Under source/test, you've got your Java source files and your resources folder. In resources, the Gherkin feature file exists, shadow_dom.feature, where all the plain English test scenarios live. In Java source, 4 packages are there: pages for the page object model, steps for writing Gherkin to Playwright code, hooks for browser lifecycle and screenshots on failure, and finally runners, the TestNG entry point. Key dependencies are in the pom.xml. The key one there is Playwright 1.44. Modern Playwright auto-pierces open shadow roots. No special syntax is actually required for most interactions now. The feature file. Here it is. Here. So this is Gherkin and it reads like plain English, which is the point of BDD. So what we're looking at here is the feature is the Vault Shadow DOM interactions. We're going to be looking at all 3 Shadow DOMs that exist on the page. So quite simple, as a QA engineer testing the Vault store, I want to interact with all 3 Shadow DOM widgets so that I can confirm they behave correctly for end users. Now here we have the background given I navigate to the Vault Shadow DOM page. So that will become the first part of every test that I run, because it's a test that they have in common, and it's a test that comes in at the beginning, so it won't break anything. So let's look at an excerpt from the feature file. So this here is organized by widget here. So widget 1 is what we're going to be looking at first, and that is the Shadow DOM form. Then we go down next to the widget 2, which is a shadow counter. So as it says there, note that each scenario gets a fresh page load, so the counter starts at 0. So this looks at part 2. And finally, widget 3. This is the one that looks at the shadow select function. You have a drop down which has a number of options you can select from it. We also have parameterized scenarios using scenario outline and an examples table. The email input test runs 3 times with 3 different email formats. Clean data driven testing here without duplicated scenarios. Finally, you can use tags like smoke or @widget1, @widget2 to let you run subsets of the testing. So it's simply maven test-d cucumber.filter.tags, and then you put in there the tag that you want to identify. So it goes and selects the test by tag, doesn't run all of them, just runs the tests that have that particular tag. Time for us to take a look at AI generated code and where it fell short. So now here's a section I want to spend some real time on, because I think it's the most valuable part of this video. The page object for this project was largely AI generated, and the AI did a solid job with the structure, the Shadow DOM traversal patterns, the JavaScript evaluation approach, the Playwright integration. But when I reviewed the code carefully, I found several places where it was technically correct but logically incomplete. Let me walk you through them. So problem 1 was with the is shadow host present. Has what I call the early return trap. So this is a presence check. It asks, does at least one shadow root exist? The moment it finds the first one, it returns true and stops. On a page with 3 shadow roots, this passes even if only 2 of them fail to load. If 1 failed to load, 2 failed to load, it will still pass the test saying that we have shadow host present. But that's not useful for us. The return true element inside this loop does act as an implicit break. So in JavaScript, a return inside a function exits the entire function immediately. It doesn't just break out of the loop. It stops everything and hands back the value to the caller at that stage. What I spotted was the missing argument. There's no way to tell this function how many shadow roots to expect. So the fix is to parameterize the function, and it's also we introduce a count. Now that we have the count and now we don't break out early, we would have a condition eventually that we assert there are 3 because we have 3 shadow DOMs. So now in Gherkin we can write, then there should be 3 shadow host elements in the page. That assertion actually means something. It will catch a widget failing to render. Let's look at the second problem here. Now, it's essentially the same issue, same fix needed for this. So this returns the moment it finds 1 accessible shadow root with children. On the Vault page there are actually 3, so this check ignores 2 of them entirely. So it provides false evidence. So the fix follows exactly the same pattern. Count accessible shadow roots and compare against an expected value. This parameterizes the expected count and asserts quality. So problem 3 that we picked up on, well that I picked up on, get select option count. So this has dead code and a hidden assumption. This one is more subtle. So if we look at this function, there are 2 variables called cell. So there are 2 cell declarations, SEL. The first searches inside shadow root. If it finds a select, it returns immediately. The second is a fallback that searches the regular DOM. On the Vault page, the select is always in a shadow root, so the fallback is dead code that will never execute. That's a dry violation and a clear clarity problem. But more importantly, the function finds the first select it encounters and returns without checking the others. If the page had two shadow DOM selects, this silently ignores the second one. The cleaner approach is to collect all selects and return them as an array, or accept an index argument to target a specific one. So look, the broader point here is that AI is a pair programmer, not a replacement. None of these were catastrophic bugs. The tests ran, they went green, but they were giving false confidence, asserting less than they claimed to assert, with logic that would silently fail in a slightly different scenario. What caught them was a human who could read code critically, understand what an assertion is actually proving, and recognize when a function is less flexible than it should be. You don't get that from running the tests, you get it from code review. AI is genuinely useful for scaffolding, boilerplate, and getting a working first pass quickly, but it doesn't think about edge cases the way a senior engineer does. It doesn't ask, what if there are 3 of these, not 1? It gives you something that works for the happy path and looks correct on the first read. The partnership model is use AI to move fast, then apply your own expertise to review what it produced. That's how you get the speed benefits without the quality costs. To be honest, the negative testing is all but non-existent in this case. We could have checked for negative counter behavior, submit the form with an empty input and ask what happens, type an extremely long string and see if this breaks the import or the layout. You could try SQL injections and so on. So what we really got was a great framework and a basic starting point for testing. Now let's look at some shadow DOM patterns that do work well. So with the caveats mentioned previously, those are all out on the table. Let me show you the patterns in this project that the AI got right and that you'll use regularly. Pattern 1, auto piercing. Page.locator, brackets input, dot first brackets, finds the input inside widget 1 without any special syntax. Playwright's engine crosses shadow boundaries automatically for open roots, whereas previously you had to specifically use the pierce argument /function. Pattern 2, JavaScript, click by exact text for the counter buttons. Filter by text is unreliable for single character symbols like the minus sign inside the shadow roots. So we use page.evaluate to walk shadow roots in JavaScript. Find buttons by exact text context match and fire the click directly in the browser. Pattern 3, leaf node text collection. To read text from shadow roots without triggering a clone node error. Shadow root does not, well, nodes are not clonable. We iterate child elements directly with query select all, skip style and script tags, and collect only from leaf nodes with no children. This prevents double counting text as you walk through the tree. These are 3 patterns, auto pierce, JS click by text, and leaf iteration, and these cover the majority of shadow DOM testing scenarios you'll encounter in the real world. Now we will run the tests from the terminal with Maven test command. Just before we start though, Chromio opens in headed mode so you can watch. Slow-mo is set to 300 milliseconds and each step has an additional pause built into it. You can follow exactly what's happening. Watch the form, it types, it clears, it retypes, it scrolls to the counter, plus button clicks with the count updating live. Then the selected drop down. Console output will show vault, counter, and select log lines confirming each action. testing an email, testing text in the shadow DOM form, so it's going to start testing different emails that we've put down as parameters in the shadow DOM form. Still more emails tested. Now the count is being tested on the right there. And again. Okay, so that's the majority of the testing done there. Okay, we'll come back and we'll have a look at the results in just a few seconds. Let's scroll down and have a quick look at the basic set of tests results. We've got test run 18, failure 0, error 0, skipped 0. It's great. Now if you look over here in the target folder, in the target you'll have the Cucumber reports, and these ones are easiest to read. So just take the report.html, copy the path, paste that in the browser window, browser URL, apologies. So look, we've got here 100% passed, 18 executed, last run 8 minutes ago, and it took 1:38 for those 18 tests to run. And you get the breakdown here. So the first test was given I navigate to the Vault Shadow DOM page, then the page title should contain Vault, and the Shadow DOM container should be visible on the page, and these are all marked with green ticks, so they've all passed. You can scroll down and you can see all the tests there. Here's another one. When I type initial text into the shadow form input, and I clear the shadow form input, and I type updated text into the shadow form input, then the shadow form input should contain updated text. We actually saw that one in the display of the testing when we run Maven test. So look, I want to thank you all for watching today. If you're not a subscriber, hit that subscribe button. And if you enjoyed the video, it'd be great if you hit the like button. Feel free to leave a comment for any further testing that you would like to see on this channel. Thank you.